Hello everyone. Today I'm going to explain a few questions from exercise 1.3. Write the following rational numbers in their decimal form and also state which are terminating and which are non-terminating repeating decimal. So they're saying these are rational numbers, P by Q form, right? um, these numbers we need to put into the decimal form, and also we need to state that which are terminating, which are non-terminating and repeating decimals. First of all, we need to understand what is terminating, what is non-terminating repeating decimal. For example, if we take a 0.30, sorry, I couldn't write here. Yeah. If we take 0.30125, okay, this is a decimal number, right? In this decimal, it is a having finite number of decimal places. 1, 2, 3, 4, 5. I can count these decimal places. It is stopped here. So this is called terminating decimal. It is called terminating decimal. For example, if I write in this way, 0.30125678, so on. This is called non-terminating decimal. This is called non-terminating. So this number has infinite numbers after the decimal place. Okay, in the decimal place value, it has infinite numbers. So we will tell it as a non-terminating. It is continuously coming. Digits are continuously coming. Okay. If we write 303030, okay, in this way, so on. So what happened? This is also non-terminating. But here in the decimal place value, 30 is continuously repeating. So we can write this 0.30 on 30 bar we will put. In the last year, I mean ninth grade, you all learnt about this. This is called non-terminating repeating. Non-terminating, repeating or recurring, repeating decimal. So we need to solve this P by Q form rational number, and we need to state that whether the decimal is a terminating or non-terminating repeating decimal. Okay. When we convert the rational numbers, either this terminating we get or non-terminating repeating decimals we'll get. We need to conclude by seeing the answer. Okay. So now let's get into the exercise. First question, 3 by 8. So 3 by 8, we need to divide and check whether it is a terminating or non-terminating. So denominator will become the divisor. And this is our dividend. See, 8 will not go in the 0 times. Okay. Now put a point here, keep a 1 0. 8 how many times? 8 threes are 24. 30 minus 24 gives 6. Already point is there, put 1 0. Next, 8 sevens are 56. So again 4, 40. 10 minus 6 is 440. Now 8 fives are 40. So we got a 0 here. So here it is 0.375. So this is called a terminating decimal, right? It has terminating decimal, we can write. It has terminating decimal. Now 229 by 400. So we need to divide even this 400, 229. Since it is a short number, I mean small number than the 400, 0 times. Now put a point and place 1 0 here. Now 229. 4 5s are 20, right? So 5 times. 4 5s are 20. So 2000 it is. So we get the remainder as a 290. Already point is there, we can place 1 0. 4 5s are 20, 4 6 are 24, 4 7s are 28, 7 times 2800. So 100, one more 0. Now 4 2s are 800. So 200, one more 0 you can put. 4 5s are 20, 2000, 2000. So 0.5725 in the decimal place. After the decimal point, we have a finite number of digits. So it is a terminating. It has a terminating decimal. So now they have given a mixed number 4 1 by 5. Convert this into improper fraction. 4 5 is 20. 20 plus 121 by 5. So we have to divide and check whether it is a terminating or non-terminating. 5 4 is 20. 1 is remainder. Put a point and keep 1 0. 5 2 is 10. So simple, right? So answer is 4.2. So it has a terminating decimal. Next. Next here 2 by 11. So 2 by 11 we need to divide it. Take the 11 as a divisor. You need to divide 2 since it is a small number 0 times. Put 1.20. 11 ones 11. So what is the remainder? 9. 90. 11 eights 88. 20. 11 ones 11. So again it's a 90. 11 eights 88. Again 10 minus 8 to 20. Again 11 ones 11. So keep on coming 1 8 1 8 1. So it's not finishing here. We won't get a 0 in this case. So we can write this as a 0.18. 18 upar ke bar. These two digits are repeating, so we can put a bar. So it's a non-terminating and repeating decimal. It has non-terminating and repeating decimal. Repeating. Next one. Fifth one, 8 by 125. We need to divide 8 with 125. So 0 times. Put a point and place 1 0. Still this 80 is less than 125. So keep one more 0, 0. 800. Now 125 6. 125 6 750. So 50 is the remainder, already placed point, so we can put 1 0. 125 4s 500. Right. So answer is 0.064. After the decimal point, we have a finite number of digits. So it is called a terminating decimal. So we can conclude it has a terminating decimal. That's it. So here are the 5 questions we can solve by simply dividing, we can find out whether it is a terminating or non-terminating. Now let's see the next question. Question number 2. Without performing division. Previous case, we performed a normal division, right? Now, without performing division, state whether the following rational numbers will have a terminating decimal form or non-terminating repeating decimal form. Here we perform the division and we concluded our answers, whether they are terminating or non-terminating repeating. Now, without performing division, we need to conclude our answer. So for that, I would like to explain this point. Let x is equal to p by q. See, our all questions are in p by q form, rational number, right? The prime factorization of q is of the form 2 power n, 5 power n. Q means this denominator only. You need to concentrate only on the denominator. In each and every rational number, the denominator prime factorization is in the form of 2 power n, 5 power m, where n, m are non-negative integers. These, when you prime factorize, the powers, whatever you get, those powers are non-negative integers. Then x has a decimal expansion with which terminates. So if your denominator is in the form of 2 power n and 5 power m, then it is a terminating decimal. If it is not in the form of 2 power n, 5 power m, then that decimal expansion is non-terminating repeating decimal. Okay. If you can put this denominator in the form of 2 power and 5 power m as a prime factor, then it is terminating. If you can't put it as a 2 power n and 5 power m, then it is not a terminating. So we can say it as a non-terminating repeating decimal. Okay. Let's see one example. But you have to remember this P by Q form. This P by Q is P and Q are coprimes. They should have a HCF 1. Okay. Coprimes means. So let's simplify question number 2 without doing the division. Without doing division, how can we conclude? We have to check whether the denominator can be written in the form of 2 power n or 5 power m. So take this and prime factorize. 5 is there, I can do directly with the 5. 5, 6 is 30, 1 is remainder 12, 5, 2 is 10, 2 is remainder 25, 5, 5 is 25. Now, 5, 1 is 5, 1 is remainder, 5, 2 is 10, 2 is remainder, 5, 5 is 25. Next, 5, 2 is 10, 2 is remainder, 5, 5 is 25. 5, 5 is 25, 5, 1 is 5. Okay. So, this can be written as 13 by 3125 is equal to 13 by 5 power 5. Okay. So, since it is in the form of 5 power 5, so it is a terminating decimal. Because here 2 power n, 5 power m we said. Either the denominator should be in the form of 2 power n or 5 power m or combination of both. Both can be there. So then we can conclude it is a terminating decimal. So I can write here it has terminating decimal. In this way, without doing actual division, we can conclude our answer. Let's do the next one. 11 by 12. What is the prime factorization of a 12? 2, 6 is 12. 2, 3 is 6. 3, 1 is 3. So we can write 11 by 12 is equal to 11 by 2 square into 3. Our denominator should contain either 2 power n form or 5 power m form or both 2 power n and 5 power m. See, here 2 power n is there, but along with this, we have one more prime factorization 3. So it is not a terminating decimal. It's a terminating, non-terminating and repeating decimal form. It has non-terminating repeating. Even though our denominator is in the form of 2 power n, but one more prime factor 3 is there. So we cannot conclude that it is a terminating. It is a non-terminating repeating decimal. Let's see another question. 64 by 455. Let's divide this with the 5. 5 nines of 45, right? 5 ones of 5. And this 91 can be divided as a 13 table goes. Prime number 13 sevens are 91 and 7 ones are 7. See, this 64 divided by 455 can be factorized as a 64 by 5 into 7 into 13. Along with the prime factorization of a 5, 7 and 13 also factors. So we cannot, same, it has non-terminating repeating decimal. Next, 15 by 1600. So 1600 with the 5. 5 3s are 15. 1 is remainder. 5 2s are 10, 20. Again 5. 5 6 are 32 is remainder 20. 5 4s are 20. Now 2. 5 doesn't go. 2 3s are 2 2s are. 2 16s are. 2 8s are. 2 4s are. 2 2s are. 2 1s are. So we can put this denominator is in the form of 2 power n. How much? How many 2's we have? 1, 2, 3, 4, 5, 6. 2 power 6 into 5 square. So this is like a 2 power n, 5 power m. So it has a terminating decimal. It has terminating decimal form. Okay. Next, fifth question. 343. Obviously, it doesn't have a factor 2, it doesn't have a factor 5, right? But still 343 we can do the prime factorization 7 table. 7 fours are 28 gone. 2 plus 4 63. 63 means 7 nines are 7 sevens are 7 ones are. So 29 by 343 is equal to 29 divided by 7 cube. A part, this denominator contains 7 as a factor and it does not contains 2 or 5 as a factor. So it has non-terminating. Repeating or recurring, both are same. Okay, next one. See, if this is directly in the form of prime factorization, this denominator contains 2 cube and 5 square, which are in the form of 2 power n and 5 power m. So this is obviously, it has a terminating decimal. It has terminating decimal. If you want, you can mention the reason since denominator is 2 power n 5 power m form. Okay. Next. See here 2 power n 5 power m along with that 7 also one of the factors. So in this case it has non-terminating repeating decimal. It has non-terminating repeating decimal. Next, ninth one. This is like a 36 by 10 square, right? This is nothing but 36 by 10. Prime factorization is 2 power 5. Sorry, 2 square and 5 square. So this is like 2 power n, 5 power m. So we can conclude it has terminating decimal. Last question, 10th one. 210, prime factorization with a 5. 5 4s are 20, 10 5 2s are 10, 42. 7 6 are 42. 2 3s are. So this can be written as 77 by 210 is equal to 77 by 2 into 3 into 5 into 7. Hey, we can 11 times. So 11 by 2 into 3 into 5. Along with the 2 and 5, there is another prime factor 3. So it is non-terminating recurring decimal. Okay. So in this, like this, we can do any sum by using division or without division also. Keep watching for more number of questions. Thank you.